Solving system of equations by substitution method. Solve one of the equations for a variable, then substitute the expression you get in step 1 instead of the variable into the other equation. Solve for the other variable, substitute the value into one of the original equations and solve. The solution will be point xy. So let's solve the system of equations. 4x plus 3y equals to 9. Now here we already have x being solved for, and we have 3y plus 6 given to us, so we don't need to solve for a variable. So now instead of x in the first equation, I'm going to plug in this expression here. The first step is to copy the first equation, which is 4, this is my x, plus 3y equals to 9. I'm going to plug in what x is in the second equation, which is 3y plus 6. This is the substitution step. And if you notice, now you only have one variable in this equation, and you know how to solve for just one variable. So let's distribute. Keep everything else as is. 4 times 3, 12. Y, 4 times 6, 24, plus 3y equals to 9. We have like terms, 12 and 3 of y plus 24. So we have 15y plus 24 equals to 9. Let's start solving. Additive inverse first. So we have minus 24 on both sides. So we have 15y. This is a 0. We have more negatives, so the difference will be negative. 9 minus 24, 15. Out of 15. Out of 15. So y equals to negative 1. Now solution looks like x value and y value. We have negative 1 for y value. We still need to calculate what x is. And I'm going to plug in negative 1 instead of that y in the second equation and keep everything else as is. So we have x equals to 3 times negative 1 plus 6. So we have x equals to negative 3 plus 6. Different signs, we look for difference, which is 3. And we had more positives, so positive 3 is our number. And 3 negative 1 is our solution. Solve the system of equations. Once again, we have x being solved for already, so instead of the x in the second equation, we're going to plug in what this expression is. So I'm going to copy the second equation as is. We have negative x, and I'm going to use parentheses instead of it, plus 2y equals to 2. And from the second equation, we have 4 minus 4y being equal to x. And now we just solve for y. That's a negative 1 in front of the parentheses. Distribute the negative. Keep everything else as is. So we have negative 4 plus 4y plus 2y equals to 2. We have like terms, minus 4 plus 4 plus 2 of y equals to 2. So we have negative 4 plus 6y equals to 2. Now we can solve for y. Additive inverse of negative 4 would be positive 4. That's a 0. So we have 6y equals to 6. Out of 6, out of 6. So 1y equals to 1. Now this is only half of the solution. It's y equals to 1. We still need to find what x is. And I'm going to plug it in into the first equation because it's already solved for x and calculations will be minimal. So we have 4 minus 4y, and we know that y is equal to 1. So we have x equals to 4 minus 4, which is 0. Here's a second part of our solution. So 0, 1 is our solution. Solve the system of equations. We have 5x plus 2y equals to 5, and the second one is 3x plus y equals to 4. When you don't have a variable already solved for, pick the one that does not have a coefficient other than 1. So this y in the second equation is just by itself. It will be easier to solve for, otherwise you will end up with fractions. I'm going to take 3x plus y equals to 4, and I'm going to solve for y. So additive inverse of 3x would be minus 3x to both sides. That's a 0. And we have y equals to 4 minus 3x. Now I solved for y from the second equation, so I'm going to substitute what y is into the first equation. So let's copy the first equation. We have 5x plus 2y equals to 5. And let's substitute what y is, which is 4 minus 3x. And now we can solve for x, because we only have one variable in this equation. So we have 4 minus 3x, that's our distribution, times 2 times 2, keep everything else as is. So we have 5x plus 8 minus 6x equals to 5. We have like terms, 5 minus 6 of x plus 8 equals to 5. So we have negative 1x plus 8 equals to 5. Now we can solve. Minus 8 minus 8. We have negative x, that's a 0, equals to, we have more negatives, so the difference will be negative 3. We need to solve for positive x, so let's divide by negative 1. Positive x equals to negative divided by negative, positive 3. Now this is only part of our solution. We need the second coordinate. And we do that by plugging in x equals to 3 into one of the original equations. And I'm going to use the second one. So we have 3x plus y equals to 4. Let's plug in 3 instead of x. So we have 3 times 3, 9, plus y equals to 4, minus 9, minus 9, that's a 0. So y equals to, we have more negatives, negative 5. So 3, negative 5 is our solution. That's all.